Hey, good morning, everyone. This is Taylor Saul, account manager for Applied CAX. I just wanted to kick off the meeting and tell you guys that we're going to be having a NX users group meeting this October 18th at the Linwood Convention Center up in Seattle. For those of you that don't know us, I'm going to give you a brief introduction. Currently, we have 30 engineers on staff and 2 account managers, so clearly our focus is on providing the best support in the industry for our Siemens NX CAM products. Applied CAX is unique as we are the only reseller to have a prototype machine shop on site running both 4 and 5 axis machines. We were recently rated #1 in the country by Siemens for providing technical support. Our focus is ensuring that our clients are getting the most out of their investment in digital manufacturing. Some of the ways that we help NX CAM clients around the country are NX post-processor development and optimization, configurable NX training classes, NX environment templates to ensure standard processes are developed and utilized in the shop, and sales and solution development for Siemens NX CAD and CAM software. Thanks for taking the time out of your day to be here with us. I hope you guys enjoy the webinar Michael's about to present.
All right, good morning, everyone. This is Michael Grant. All right, well, today I wanted to go over some surfacing solutions for when you're doing advanced 5-axis. Hoping to give you more tools in your toolbox as far as when you deal with certain parts that might be giving you trouble. Depending on how parts are modeled and the quality and also where they come from, which CAD system, will determine how easy it is to program in 5-axis, especially when you encounter swarf type faces that just don't make any other type of tool axis work well in the 5-axis realm. As you can see here, there's quite a bit of twist on these faces, which doesn't make something like away from line or towards or away from point type of tool axis work very well. So when you encounter faces like this, you certainly need to be able to look at the U and V lines. And if you're not aware, CAM systems look at either edges or UV lines as one solution for multi-axis swarf cutting. So we have a machine shop here. We're making parts day in and day out, complex parts. We have a 5-axis DMU 50. And so we encounter the same things and just wanted to share some of what we've learned. And so I'll show you a couple different ways to deal with it. Certainly NX11 seems to be doing a better job of trying. When I show you this part, you'll see what I'm talking about. This particular part does not have good data, so I'll go ahead and start showing you that. So this will be kind of an overview of some different methods to help clean up surfaces or create good reference surfaces. So this is using the modeling and CAM of NX. So this would be equivalent to having a CAD CAM package. All right, so I'll go ahead and switch to wireframe view on this part here. And I'll show you how I got this view here as far as seeing the U and V lines. But this is, like this face here, that would be something that NX would derive the tool axis from. It would follow that if edges didn't work. And as you can see on this particular face, that might work well, but as it gets into the corner there, it would cause some major swinging of the tool axis. Let me go ahead and switch something here. All right, so I'll go ahead and trying to keep it from highlighting here. All right, sorry, under selection. There we go. Okay, so as you can see here, and then this face here in the corner, I'll go back to shaded, definitely has some crazy UV lines. And so just to show, because we're an engineering services company also, so we we do design in several different CAD packages depending on what our customers' requirements are. So this particular part came from SolidWorks, and so just to show that it's not a translation issue, I extracted the face curves of this SolidWorks part, and you can see that we're getting the same data. So if I go to face curves, you can see, I'll do one more here. Doesn't like that particular face. All right, well, it's decided to quit doing that. But you can see here, I'm not, this isn't any tricks or anything. This is exactly what we're getting. So I'll show you how I got this type of analysis in NX. There's several ways, but one of the methods I use, I haven't done anything on these faces here, as you can see. So what I normally do is switch to a face type selection. I won't do all of them, but then you can do edit display, Control J. And then under your object display, you have this under wireframe display. You can show U and V and just put some numbers in there. And then when you switch to wireframe view, now it has to be full wireframe and not wireframe with hidden edges. I switch back and forth a lot, so I have that set up on my mouse. I just kind of tilt my mouse wheel one way, and it has the shortcut Alt-W, as you can see, and then for shaded with edges, Alt-Q. So my mouse is just enacting some shortcuts. Now, one thing I didn't, another thing, this webinar is assuming you've used NX, you're an NX user. If you haven't, I hope you find it interesting and see kind of how 5-axis cam works and learn something from it. Certainly reach out to us and let us know if you have questions. So this is assuming you're an NX cam user that is doing multi-axis toolpaths. All right, so I have a contour profile toolpath here, and so on this particular window pocket with the bad U and V lines, if I go and kind of step through this toolpath, maybe even just slow it down. So you'll watch in this corner, it kind of gets a little kick there. Not too bad, and if I go back there, there's a couple moves. And like I said, 11 is doing a better job with this. I like this toolpath. It's a quick way to get some multi-axis toolpath, and I'll show you how I created it. And there was another kind of a quick kick there with the axis. I believe I have this ready to simulate, so I will try that. So this is our G-code simulator, and go ahead and slow it down, show the machine. And if I hide this window, you can see the G-code. There's the interesting moves. All right, so we'll go ahead and try to improve that. And I'll go ahead and I'll hide the machine there for a moment. So with this toolpath, I'll create another. But basically, the only things I've done is selected some walls. If you have a floor, you would pick the floor and then have it automatically pick up the walls. So this automatic walls would be selected. In this case, we don't have a floor, but I will show you an option of creating your own floor. And then, so when you don't have a floor, you can check the automatic auxiliary floor, and it will create a floor. You can move that up and down. In this case, there's just too much swarf for that automatic floor to work well. So I've went and checked follow wall bottom. So if I was to create, we'll create another toolpath for over here, but we'll go ahead and improve these surfaces on this particular window over here, and then we'll create a new toolpath using the same cutter. So one method you can do, I don't see any chats. I'm just going to check and see if anybody's got any chats in regards to audio. I don't see anything. Okay. All right, so one thing you can do is delete face. So if I delete this corner, and then I choose not to heal, and I'll go ahead and switch over to modeling. And then in surfacing, I'll go ahead and add a new surface. And then I'll sew that back so that it's a solid. And then we'll go and add that back to the analysis as far as the UV lines. And you can see it's done a great job of lining the UV. So we'll go ahead and do one more face here. And so this is where, in my opinion, NX, it just really adds power to your CAD CAM world. Just having the CAD is amazing. It definitely helps get your toolpaths done quicker. You have just more options. You have a larger tool chest. Rather than sitting and staring at it and going, what am I going to do? You can do quick processes like this. You have a lot of different ways you can do this. It's extremely flexible, fast. I just really enjoy this part of, making things work and getting the part programmed with a good quality toolpath, which is it's gonna reflect in your part finish. When you have the cutter acting, the end mill acting as it should, as it transitions, your part finishes are going to go up. Your programming time is much faster. When we've encountered some really extremely difficult parts to program that were modeled in SolidWorks, just because SolidWorks isn't it's not really looking at how it's creating the UV lines. It's just all about just modeling it up and then passing that issue on to manufacturing. But here, NX, it's doing everything in one, so it knows that it better do a good job of modeling in order to make manufacturing easier. So we didn't even model this part. We're putting exactly the same faces in, it's that we had, and getting excellent UV line alignment. And we didn't even, again, we didn't even model this part in here, and it took a few moments to do this. And the way that NX assemblies work in CAM, we're not even affecting the engineered part that was sent to us. We haven't touched it. We haven't resaved it. This is an associative copy for manufacturing. It'll update. Even if we do modifications like this, we can do analysis to compare it to the original part, so we can overlay faces and look at, like we are here, this is two of the parts overlaying as far as the untouched engineering model versus the optimized manufacturing model. All right, so I'll go ahead and continue around there. I'll just continue deleting. I think I need to go up to about there. Might have been. We'll see how this. It might have been better to leave a couple, which is fine. All right, we'll go add that back in and apply. There's always a little bit of the webinar nerves. All right, and we'll add those. Turn off preview, that'll speed it up a little bit. All right, and then we got them going the same way. I think I made a mistake there. Just reset the rotation center for the 3D mouse. That often helps a lot. And now we'll do a so. And then we'll go back to the analysis. I'm trying to remember which ones I haven't added. There we go. So I've had it to where it didn't even add these lines in the center, but I'm kind of rushing through this, but it's still giving us great data. So we'll go ahead and add the UV line analysis and switch over. So we've got all of the lines are aligned. You can see how they meet up there and transfer around. All right, so on the smaller faces, 5 will show more lines, but they're just more condensed as far as that's probably the V. All right, so go back and we'll add a new toolpath to that. And look at what tool this is in and just add another one from scratch. So operation, multi-axis, contour profile. I believe I want that in the finish part. Just double check. Yep. And then we'll say OK. Turn off automatic walls. Turn on automatic auxiliary floor. And then pick the walls. All right. And then we'll say follow wall bottom and generate. I don't remember picking. Looks like I need to offset it down a bit. Oh, I don't have my, let's see, specify. I don't have the center curve. I'll go ahead and try. There's still a little bit of kicking there. So we'll set the access vectors for the start and end of cut. And then I'll reset this to the same one. So there we go. We've got a nice clean transition other than one corner. So we can switch to also have better control. We can switch the way that it's looking at the info. And then swarf base. And then we'll run through that. I think not having that center line, so I'll show you what I have on the other pocket. I probably should have stuck to one pocket. So one thing I did for the access vector on the other pocket is extracted a center line so that I would have, basically an equal access to the pocket. Okay, so the other option with that is to you can either delete and recreate the faces, or another way that's helpful is to recreate your own floor. So you can either create the floor here and move the curves down, or you can move the curves down and then create the floor. So I'll show you. I'll extract the curves and then move the curves down. So we'll say tangent. And then we'll translate those down. All right, so then we'll move those down. And then we'll maybe a little further. So we have the curves. Now one that I like to use is end-sided surface. And then I'll just say trim. I probably should actually, let's do that one more time to the our second contour profile here. Yeah, so that one right there. I'll do that. I'll move that toolpath over to the one with the floor. So these don't have a good UV line structure, but we've created a floor. And we could extend that floor out. It should be enough. And then we'll regenerate. And we'll add that floor to our part geometry. and reset our vectors. The vector customization for your start and end curves are only if you have kind of a lack of data. It's kind of one way to one type of workaround. If you have good wall or floor, it usually helps, and NX will figure it out, and not you won't have to have the curve specified in the start and end toolpaths. And we'll go ahead and set this. So it probably would have been better to start from scratch, because I went and customized this toolpath away from all the automatic settings, and now I'm trying to undo all of that. There we go. That'll teach me. So you can see with the floor, in this case, it's really nice. Next time, just start from scratch. And you can see we're also using the UV line, the surfaces with the poor UV lines. During this demonstration, I must have had a setting wrong, but that happens. And so I just want to show you several different methods to help, because there's always one solution that works better than another given a certain part. I've had parts that a particular solution that worked great on the previous does not work well. So you really need to have multiple methods of solving bad data, or just getting a good tool path. We have there's certain cases, not so much with this one because the wall is not too deep, but there's particular cases where the data was so bad, but that it just it was hard to even repair, and so the effort to try to get a swarf toolpath, just being a one-off part, we had to switch to a different method, and you're talking, oh man, I would say 20x the toolpath time. The programming time was shorter, but we had to do a step down or a stitching type toolpath. And so if we would have gotten good data, if the part had been modeled in NX, or and had good data, we could have put toolpath on it extremely quickly because of the good UV lines, and we could have created a toolpath that was 20x faster, because it could have used the side of the cutter instead of having to step down at multiple tool axes or fixed tool axes, 3+2 machining. All right, so here we created the floor. The other, so you can fix the faces, recreate the floor, are a couple different ways that I've used. And when creating the faces, it's probably better to delete, one at a time, so you have good edge data. That was one of the mistakes I made. So, if you're deleting this face, then patch it before deleting this one, or you can either extract these curves so that you have them there in order to recreate similar face geometry as to what was there. So I'm just clicking all of these edges, and basically I could even do it all in one, and then saying OK. And so if I delete all of these faces like I did previously, I still have edges that I can select when recreating. And so I'll go down to the cross curves. And then apply. And then same thing here. and then we'll add the cross curves. And then if we look at the faces, sometimes less data is better. You know, kind of like a spline with fewer points is going to be smoother. So we still have, actually in that case that messed up the UV, so we'll go ahead and, this is associative, so we can go ahead and remove those cross curves and go back to the other one. And then that gave us the cleaner faces. So in this particular case, I would just use the edges of the face, but it's an option to be able to recreate those curves. All right, and then when you're using the multi-axis contour profile, you have your tool axis here, where you can, try to use the edges. So if I recreate that, it's basically going to try to align the tool to those edges that you can see. And then if a contour profile, another option for a tool path is basically a streamline, variable axis streamline. And so that is here. We'll go ahead and use the same tool. We have our part selected, and we'll pick the cut faces. And then that will create the cross curves. So basically the way that we were modeling this basically extracts the same type of data, your cross curves, or your flow curves and your cross curves. In this case, we just have the flow curves. I'll go ahead and set the cut direction. I should double check the material side. And then for that, I would use normal to drive and swarf. And then you'll have, similar to the contour profile, you have grid or trim, base UV. And so again, it's looking at that data of the faces. So if we try this on the other face, with the good UV lines, we should get, and we can try even switching to swarf. So we'll go ahead and inspect, what tool axis we're getting here to make sure the type of behavior we're getting. So it is contacting correctly. In that case, I would say it's probably the projection. So we'll go ahead and you can even, whenever using swarf drive, then you're allowed to use the swarf vector. 9:05.
Is it over?
No, it goes to 9:30. Yeah. All right, so you can see, I mean, the definitely the quality of the faces has an effect. You know, whenever you're processing for, you know, trying different methods, what I would suggest is just to get quicker um, toolpath creation times is to turn off your collision so that you'll get a quicker your toolpath. You'll see what your results a lot faster, and then after that you can turn them back on if you have any issues. Normally with this type of machining, I don't see a lot of collisions, and here we're checking that against the actual machine movement with the G-code simulation. So that will basically show any collisions, and then you can resolve them from there. So here we'll play through this. Let's watch it in the corner there. So not bad. This is pretty good result. We got a few lifts at the bottom when it's below the contact point. It's pretty smooth coming in. This is a helical toolpath, and then if we compare that to like the base UV, I'm sure this will have. So Siemens is basically giving you two methods. It's trying NX is trying to give you two options there with the base UV and the swarf in case you do have bad model data. So here's looking at the swarf, but if we copy this, let me check which one I had smoothed out here. So I believe it's that one there. Okay, so we'll copy that over. I could have got rid of a few of those lines there, but they're still a good data as far as U and V. You got to double check the flow curves to see if it recreated them. So right now those are set to automatic, but you have the ability to specify. There are times you'll get crazy, flow curves just because it's trying to do it automatically, but you can switch this to specify. And similar to the way I was recreating the surfaces, you can just select the curves as you see fit. And then also you can now interpolate on faces. Let's go ahead and all right. The directions are good. We'll switch back to grid. Interesting. Okay. There's some, it could be the extra edge on there. Let's go ahead and recreate these. Oh, as far as cut direction too. And then flip material. So now you can see that the swarf, now that we have good UV lines, has better data. Because well, this is actually base UV. The edge type of extraction doesn't always work because you have sometimes you have edges that just won't drive the toolpath well. They're going to they just have too much tilt from one edge to another. And there we go. So this is a continuous toolpath. So if I play this through, speed it up a little bit. So it doesn't retract. It engages once. We're getting a little bit better. Before we had multiples. This one, since we cleaned up the faces, is much cleaner. So the last part I want to show, it doesn't really relate as much to this part, but a few more tricks as far as you guys know when you need reference surfaces for multi-axis toolpaths. That would be more of a surface area type of cut. So what I'll do is switch back over to modeling. So whenever you need to create your own surfaces, maybe a really clean, I'll show you one if you wanted a really clean a surface without any edges. So what I would do for that is basically create a spline and just get something close by picking these. That might be a little too much, so we might not be able to go all the way around this. And so now we can smooth those out. Let's say 1. Yeah, this might not be a good scene here for G0. You start that over. So that I might have got a little carried away with going too far there. So I'll just wrap this curve here, because normally you're not having to go all the way around. And then I can smooth that out. Something. So you can basically manipulate the spline in 3D space. One of the ways I like to do it is normal to WCS, so you can kind of tell what vectors you're using. But now we have a smooth spline. Would certainly drag this over a little bit. So we'll say OK, and then we can copy that spline and basically translate it down. We can make the translation normal to the edge. So I just moved that handle normal to edge, and now I can drag that down, and I'll say copy. Then I'll switch to wireframe, or you can hide your model. I like Studio, but you can also use through curves. It depends on the license you have. So there we have, a very clean, smooth surface. You could use that as a reference surface for something like surface area toolpath. You can even control surface area. Allows you to use your surfaces to control the tool axis. So if you have something with a crazy face normals, you can smooth that out with this reference surface that not only will project the toolpath, but you can use it as a drive geometry for the normals for your toolpath. So to show that, let me roll back here to give you kind of an idea what that looks like. Let's pull this further down. hide the other one. All right, so now we have something a little bit more, I guess I could use even the floor too. So we have the ability to modify like the U and V's of a face. So like here's that floor we were using. So I could say the floor has only 3, something like that, and it has a lot less information, which makes it a little easier to smooth out. So I could pick this whole pole and kind of manipulate the face. So if this was controlling your tool axis, that gives you a little bit better ability to smooth out your tool axis, but also manipulate your face. So if I don't want the whole thing, I can grab just a point. So that's definitely a handy tool. The other is that I use a lot is extract face, or sorry, enlarge. So if I wanted to get a reference from this here, I can pick that face with the enlarge command and basically just pull my edges. So I could use this as a reference surface for projecting a toolpath. Again, this particular part's swarf based, but I don't have time to go through all of the different toolpath types, but I wanted to be able to show you some of the benefits of being able to go into modeling and using the advanced surface features. You can also, on the curve toolbar, another one I like is either offset curve and face. So I've used this when I'm maybe remachining a corner and I know what size my tool is, and I want to have, I just want to split the face. And instead of trying to trim it or use rest mill, which can take longer to process, I'll just pick the curve and the face, and then you can just offset it by whatever distance. We're in millimeter right now, but you can see it's normal to the face. So I could set this up, I don't know, -1 on this side, maybe -1 on this side, or +1. And then I could go into, maybe a divide face. And pick those 2 lines. Actually, I don't think I could do both at the same time, so. And then do the other one. And then, I can even color those sections to know, they're, maybe for a different tool path. So quickly, modifying faces. And again, this is a manufacturing reference model, so we're not affecting the engineer part. You can also extract using the curvature, similar to the offset curve. You can extract curves on the face, the U or the V lines, or both, and sometimes I use this to trim a face. So right there I just quickly create a curve normal to the UV lines of that face, and I could use that to trim it. I could set this at a distance, a relative distance, or you can have it uniform. Another, let's see, that was that one. Bridge curve can be handy for smoothing. So if we had done, let's hide the model. Hide some faces here. So let's say we had these 2 sets. maybe, whoops, do that again. We had them over here and we flip them around. That's a little extreme, but something like that. You just have curves you want to connect and you want it to be smooth. So another one is the bridge curve. Basically you pick this curve and that curve, and it does a smooth line between normal and tangent to the lines. I should have just left the command up. So now they're connected, so we'll do single. If you hit I'm just hitting my mouse. If you hit apply once, it would stay up. So if I do this now, if I had done that again, it would have stayed up. So I'll show you. That's kind of a cool command. So I'm using my middle mouse to say accept. So I'll hide those to show again, because that's kind of, so I click the line, click the center mouse, click the center line, or the next line, hit apply. Now when I do that again, the center mouse will move to the next box and hit apply without closing the dialog. So it stayed open. So you can just quickly go through doing something over and over again without even taking your hand off of your mouse and just hitting apply with the center mouse. So, a lot of different options here as far as, I just find and everybody I know that does multi-axis finds having the ability to quickly create reference curves and surfaces just helps create a cleaner toolpath, a higher quality surfaces, faster machine times. And so having the ability right in the same system as your CAM to be able to quickly create those without having to go to another application, create them, export, import, and try, and then go, just go back and forth. Here it's just apply, application, modeling, application, manufacturing. You instantly get feedback as far as what the results are, and I just find it's a lot quicker. And NX, it has a lot of capabilities, a lot of tools, a lot of different ways you can do create surfaces quickly. With the insided surface, it's an amazing tool. Basically smooth surface there with one click. Another smooth surface. I could do the studio, which was what I've been using, or the through curves. I can basically connect these quickly. Going the same way, and just amazing. I love it. It's very powerful and fast, and just insanely good information as far as your UV lines for manufacturing. So I guess I forgot to click one, but I've even found, I guess last thing to show, let's say fillets. So if we look at these fillets here, or radiuses, whatever you want to call them, and we look at the UV lines of those, forgot one there. Not too bad in this case. Let's look at the other one. But same thing, delete and recreate. It just recreates great surfaces, even just on an imported model. So you can quickly optimize your models for manufacturing without having to export. These particular, I might have already redone them, but they're okay. So in this case, we don't need to. But recreating a fillet is as easy as like we were doing before, delete face and recreate, or you can delete the entire. You can get the size of the radius, and then in this particular case, it might be B surface, but No, it's not. So it recognizes this is a blend and what size it is. I can either modify that or use that for reference when use it for reference to recreate one. So I can copy and paste that. When I delete and recreate a fillet, I can use that number. But right there, even though I didn't model it in here, I can change the size, update it that fast. And they already look better. It had a little bit of a weird line there. But anyway, I'll open it up for questions. I hope you guys found this helpful. We'll have some stuff to share for you guys to look at and play around with as far as tool paths and surfaces. We'll upload a recording of this, and definitely open for questions now if you want to ask through the chat, or let me know if you want to be unmuted, and we'll open up the mic.
Yeah, guys, we'd like to make these webinars as interactive as possible, so please feel free to ask as many questions as you might have. Also, while we're waiting, I'd like to point out that we have an upcoming CAD foundation class and a CAM foundation class in September. Michael Grant will be running his on the 25th through 28th here at our facility in Portland, Oregon.
All right. Yeah, one question on how to machine the fillet. I think in this case, all right, so the fillet, let me think about that. Probably just the streamline type operation, and using the same, let's see here. Let's try the streamline. I can certainly add that. Yeah, I might not be able to do that in a few minutes here, but I'll add that to the sample so that you have that for reference. Let's see who asked that. Yeah, that was for Brent. So I'll have that added to this sample. I would use the streamline and do you could do the helix type where it only engages once and then retracts once, so that'd be nice and clean. But it would be a stitch type toolpath unless you had like a form cutter or a radius cutter. Well, thank you everyone for attending, and we'll have some information for the next one.
Yeah, if you guys have any suggestions of topics that you'd like to see covered in upcoming webinars, we'll be hosting another one probably in October. So if you have any suggestions, please email me, tsaul@appliedcax.com, or Michael Grant, mgrant@appliedcax.com. We'd love any suggestions and are always looking for topics to have covered. All right. Do we have any other questions?
No, that's it.
All right. Thanks.
Thank you, everyone.